All right, group. Today we're looking at fractional equations, or also known as rational equations. Okay. Here's an example of what we're going to be solving, but let's look at my rules first. So one of the very first things, so we always got to make sure the denominators are in factored form. Okay, all your denominators have to be in factored form. This one's not in factored form, so we're going to have to get this in factored form. Also, notice this one right here is backwards. That's saying 2 minus x. We want them all the same. So we want the x's in front. So number one, get the denominators in factored form. So let's get that taken care of right now. So this has to get factored. X minus 2, x plus 2. That's set. This is 2 minus x. We don't want a 2 minus x. We want it to say x minus 2. So I have to rewrite that. Now, if I rewrite that as an x minus 2, that means I multiplied the bottom expression by a negative 1. Well, if I multiply the bottom by a negative 1, I have to multiply the top by a negative 1. So I'm going to put a negative 1 up there. Okay? So when you rewrite this as x minus 2, you have to remember that this is multiplying by a negative 1. So we multiplied this fraction by a negative 1. So technically I multiplied the top by a negative 1. Okay, so I see my negative there. And now notice I have a double negative. So that double negative there just makes this equation becomes plus. Okay. All right, let's keep going. You are going to see this in your paper. So when you see this 2 minus x, rewrite it and then multiply the top by a negative 1. Okay, then just be careful of your signs. All right, now 2, we're going to make the common denominator. Okay, just like when you did complex fractions, we multiplied everything by the common denominator because that makes the denominator pieces cancel out. Okay, so we're doing the same thing. So here's my common d over here, common d. I'm gonna write it out over here. So they have these two pieces. There's an x plus 2 here, and there's an x plus 2 here. They have an x plus 2 in common, and these two have an x minus 2. So our common denominator is x plus 2, x minus 2. Okay. This is how I do my work. I multiply everything by the common denominator to make these denominators cancel out, so I'm not looking at fractions anymore. I know if you look at some videos and such, you know, those folks will probably say, oh, we got to multiply this top and bottom by an x minus 2, and this top and bottom here by an x plus 2. And then you can cancel out all the denominators because all the denominators are the same. I just do it in one step. Multiply everything by the common denominator. If you know what to multiply top and bottom by on each of them, then you know what the common denominator is. And then that's what you're going to multiply each of your terms by. I'm multiplying this by an x plus 2, x minus 2. So things cancel. We're going to multiply this by an x plus 2, x minus 2. We're going to multiply this, get that out of the way, by an x plus 2, x minus 2. Why am I doing that? To make all of these denominators cancel out. So x plus 2 cancels with the x plus 2, so we're just left with 2 times the x minus 2. So if you want to write this out, you can. I'm going to go do this, 2x minus 4. Okay. Here, x minus 2 cancels with the x minus 2, so we have x, remember this is double negative here, becomes plus. We took care of that already. So I have x times x plus 2. So we have a plus x times an x plus 2. Well, so that's your plus x squared plus 2x. You won't see me do this. If you need to do this, you can. Nothing wrong with it. I usually just go right to here. Okay, now here, all of this cancels with all of that, so we're just left with x squared plus 4. So equals x squared plus 4. All right. We got to combine. What do we got? 4x here. I'm going to put that x squared first. Now notice this x squared and that x squared, it looks like a quadratic. So I have to get all the, looks like we got to get everything on one side, but what happens with this x squared and that x squared? That's right, there's an equal, they're cancel out. So this is not even a quadratic. Some of your answers may be quadratic, some of your work may not be quadratics. No big deal, don't worry about it, just do your algebra. If it's a quadratic, make it t equal to 0, factor. This is not a quadratic, I can just start solving. I'll add 4, divide, x equals 2. Okay, so we did the solving part. Now we're going to do the check. The check is very important because we cannot have a 0 in the denominator because these are fractions that would make it undefined. And look at what happens when I plug in 2 right here. Either one of those spots. 2 minus 2. 2 minus 2 is 0. We cannot have 0 in the denominator. Therefore, this 2 gets tossed. All right, so now what does that mean for us? We have no other number to worry about to check. So are there any answers here? No, the only answer that we had, we threw out. So that's right, this is called the empty set. Okay, so this one has no answers. No answers. Okay. Okay, let's look at another one. All right, here we go, number 2. A little bit more challenging. Number 1, denominators, are they in factored form? Yes, they are. So we have to create the common denominator. So our common D. Okay, so this has an x minus 2. This has an x plus 2. That's right, your common denominator is just their product. 1, there's no denominators to look at. So there's our common denominator, x minus 2, x plus 2. Okay, so now we multiply each term by the common denominator. Why am I doing that? That's right, to make the denominators cancel out. So x minus 2, x plus 2. X minus 2, x plus 2. X minus 2, x plus 2. All right, so here, x minus 2 cancels with an x minus 2, so I'm left with x times each of those. So x squared plus 2x, x times each of those. Now this one I'm going to do a little bit different. Okay, I'm going to do my canceling, so x plus 2 cancels. But here I have a big whammy. We have this big giant minus sign that we have to worry about. That big giant minus sign we have to worry about. So we have minus the quantity of x minus 2 times x plus 7. Okay. Then it's equal to, now I have this product, x minus 2 times x plus 1. X minus 2 times x plus 2. So 1 times that. So I don't need to say 1 times that. I mean, if it was a 2 or a 3 or 4, then obviously we would put, like 2 big giant parentheses. Okay, notice no more fractions. So we have our work cut out for us now. So I have x squared plus 2x minus the quantity equals, and then we got to multiply this out also. And hopefully you can do that one in your head. That's right, x squared minus 4. This is your dots, okay? Do your little box if you have to. Okay, if you want, I'll do the box for this over. Actually, I'll just do it in my head. X squared plus 5x minus 14. Okay, if you're not sure where that came from, do your little box. I'll set it up. So I got x minus 2, x plus 7. You guys can multiply that out. Okay. Here I have to distribute my negative. So I have x squared plus 2x minus x squared minus 5x plus 14 equals x squared minus 4. Now, I'm going to combine like terms on the left-hand side. And when I combine, it looks like my x squares cancel. So I'm going to have, what's this, a negative 3x plus 14 equals x squared minus 4. And now I'm going to set this to 0. So I'm going to add 3x. I'm going to subtract 14. So 0 equals x squared plus 3x. Then I'm subtracting 14. So minus 18. Okay, so I subtracted 14 from both sides. Let's just sit there first. All right, now I'm ready to factor. That's right, 6 and 3. So you have x and x. That's right, 6 is the plus, 3 is the minus. So we have our possible solutions of a negative 6 and a positive 3. Now, the check. Remember, we always have to check because we cannot have a 0 in the denominator. Does a negative 6 make 0 in the denominator? No, it does not. That's right. Does 3 make a 0 in the denominator? No, it does not. So these are both keepers. Okay? Folks, don't use parentheses to say my answers, because if you use parentheses, this is interval notation, or it's an ordered pair. The answers aren't between negative 6 and 3. The answers are a negative 6 and a 3. So that would be the little squiggly brackets. That's your set notation. Okay? Or else just circle. But don't use parentheses. Okay. So that was a nice one. It was a quadratic. We had a factor, came up with 2 possible answers, and we can keep them both. All right, now we're on number 3. So, number 3, here we go. We have to factor. Rule number 1, get your denominators in factored form. Oh, that's a nice, easy one to factor. X minus 1, x plus 1. That's already done. Here, oh, that's right, pull out a 2, x minus 1. All right, looks a little messy because there's a lot of stuff going on in the denominator. So I'm going to write it out over here. Our common D. Let's see, what do they have? Oh, we got x plus 1s. I'll write that down. We have an x minus 1. So we got an x plus 1 and an x minus 1. What? Oh, wait, and there's a 2 right here. Don't lose that 2. So the 2, x plus 1, x minus 1, all of this is the common denominator. That's right, there's a lot here. So, but we're going to multiply everything by 2, x plus 1, x minus 1. 2 parentheses, x plus 1, x minus 1. It just takes a long time to do the setup. But once you get things started, remember, the reason why I do this is to make the denominators disappear. Okay. Now it's just cancel. Cancel, cancel, cancel now. So look at this canceling. All of this cancels out. Gone, gone. So I'm just left with a 2 and an x. 2x. Look at this. X plus 1 cancels. You cannot cancel those two 2's. You got to multiply them together. Those two 2's do not cancel. We have multiplying. So you have plus, you have 2 times 2 is a 4 times the x minus 1. Okay? I would have just multiplied it out in my head, but so it's 4 times the x minus 1. Now over here, what can we cancel? Well, this 2 cancels. And the x minus 1 cancels. So we have 1 times x plus 1. Hey, you know what? I don't see any x squared terms. So this is not a quadratic. So we don't have to worry about setting it equal to 0. It's just a straightforward equation solving linear equation. No quadratics here. We don't have to worry about making it say equal to 0. So plus 4x minus 4 equals x plus 1. Let me combine those. All right, you guys are in pre-calc. I'm going to do this in one step. I'm going to subtract x to the left. I'm going to add 4 to the right. So I have a 5x equals 5. So I subtracted x to the left, added 4 to the right. So that means x equals 1. Okay? Now we have to do our check. All right, we only have one number to check. Remember, the reason why we're doing the check, no zeros in the denominator. Well, let's see. Right here, what happens when I plug in 1? Well, 1 squared is 1, minus 1 is 0. Guess what? We can't keep it. So this one is another empty set. Oop. There we go. Another empty set, folks. All right. If you guys like my little sad face for an empty set. All right, so that's it. That's our rational equations work.